always find that robot voice just a little bit weird. Anyhow, this Zoom session is being brought to you by the Fractal Crystal Ball. And today we'll be discussing intermediate algebra, section 1.1 and sections 1.2. Okay, first section is about variables, constants, and expressions. The first thing to note is the most important number in algebra is x, denoting the unknown, a variable constant whose value are attempting to determine. So it's a variable, the number whose an unknown value. Usually it's simplified by x, but usually we use letters at the end of the alphabet. X, Y, Z, U, V, and W. Sometimes letters A, B, and C. Well, there are 26 possibilities. And sometimes because there's more than 26 unknown things in the universe, we use subscripts. X1, X2, X3, X4. The 1, 2, 3, 4 don't have nothing to do with the numerical value of the variable. It's just different. It's a list of different unknown things. A constant, that's a number with a fixed value. 117, 11 thirds, -42, square root of 2, pi, e, and it goes on forever from there. Operations work on constants and variables. Addition, plus, minus, subtraction, times, divide, exponential, and there will be many others, but those are the basic ones. We build an algebraic expression up from constants, variables, and operators. For example, here's a rectangle, length L and width W. The perimeter is twice the length plus twice the width, 2 times L plus 2 times W. Its area is length times width, L times W. Here are some other algebraic expressions. Pi r squared, that's the area of the circle with radius r. X squared plus 2x plus 1. Y cubed plus 1 divided by y plus 1, and so on. And again, potentially infinitely many others. You evaluate an expression by substituting giving constant values for the variables and calculating. For example, going back to this rectangle length and width L and W. If it's a length of 3 and width of 2, and here we're leaving aside the question of units, then the perimeter is 2L plus 2W is 2 times 3 plus 2 times 2. That's 6 plus 10 plus 4 makes 10. Length times width is 3 times 2 is 6. This expression x squared plus 2x plus 1, when x equals 5, that's going to be 5 squared plus twice 5 plus 1. That's 25 plus 10 plus 1 makes 36. This expression y cubed plus 1 over y plus 1 when y equals 2 equals 2 cubed plus 1 divided by 2 plus 1. 2 cubed is 8. 8 plus 1 is 8 plus 1 over 3. It's 9 thirds is 3. So those are, okay, so we have variables, constants, and operators, which are combined to expressions, which we can evaluate. An algebraic equation states that two algebraic expressions equal each other. For example, 2n minus 1 equals 13. Or x squared plus 2x plus 1 equals x plus 1 squared. Or z plus 1 equals z. Okay, a solution to an equation is a value for a variable that makes the equation true. For example, 2n minus 1, if you said n equal to 7, twice 7 minus 1 is 14 minus 1 is 13. So this expression, this equation, 2n minus 1 equals 13 is true if n equals 7. Now here, this is an equation, x squared plus 2x plus 1 equals x plus 1 all squared. That's true for any value of x. This is called an identity. These expressions are identical. Here, however, on the other hand, z plus 1 equals z, that's an equation which is true for no value of z. That's called a contradiction. This equation 2x minus 1 equals 13 has one solution, 7 and 7 only. Here's an equation x squared plus equals x. It has two solutions, 0 squared equals 0 and 1 squared equals 1. So 0 and 1 are solutions. Here's an equation with three solutions, x cubed equals x. That's true if x equals -1, or if x equals 0, or if x equals 1. -1 cubed equals -1, 0 cubed equals 0, 1 cubed equals 1. Here's an equation that's true for all numbers. 3 times x plus 2 equals 3x plus 6. This is true for any value of x. We denote such a thing, an identity it's called, by putting 3 lines instead of 2. So it's sort of like a strong equation. They're not only equal, they're always equal for any x. Here's an equation which is solved by no numbers. 3 times x plus 2 is never equal to 3x plus 5. So maybe I should say equals for no x. And in algebra, basically what we'll be doing most of the time is solving equations. Trying to find the unknown given some equation that we know about it. Okay. In a certain sense, I think of an algebraic expression as like a noun phrase. This and equals, we put an equals between them. That's the closest algebra gets to a sentence. This is that. And really, generally the only verb available in algebra is the word equals. Fairly limited in artificial language. That's sort of the whole thing about that. Okay, now here's some examples. Let's translate into algebra the expression, the product of d and 4 decreased by 15. Okay, the product of d and 4, that's 4d. Decreased by means subtract 15. 4d minus 15. So this is the name of, same name as this. Both name and number. Okay, here translate into algebra. A married couple agrees to split their tax refund. He donates 75% of his share to charity. If T is the tax refund and H is the husband's final share, then what's his share? Okay, fine. Well, T is the tax refund. We split into a half T. Then he donates $75 to charity. So the husband's share is a half T minus 75. So this is the equation. Here we will be doing table filling. We'll be given an equation, C equals P over 12. And for various values of P, what is C? So if P is 24, C is 24 over 12, which is 2. If P is 72, C is 72 over 12, which is 6. If P is 180, then P over 12, C is 15. And we'll be doing a lot of table filling later on when we do graphing, as you start with an equation, make a table from it, and from the table, make a graph. Here we have 2 slightly different expressions which translate into algebra in slightly different ways. Expression A, 6 miles more than 15.5% of the altitude, and B is 15.5% of 6 miles more than the altitude. Here, for the first one, we take the altitude A, find 15.5% of it, and add 6. Here we take the altitude A, add 6, and multiply by 15.5. So A is 0.155A plus 6. It starts with A, multiplies by 0.1155, then adds 6. For B, we start with A, you add 6, and multiply by 0.155. So 0.155 times parent, A plus 6, and parent. We use these parentheses. I suppose that's also part of an algebraic expression as a kind of punctuation, as a way of telling you which to do first. In this case, the addition first. In this case, the multiplication first. So, okay, now that I think about it, really we should add parentheses and other punctuation as part of an algebraic expression. Okay, now you see here we have this video lecture from previous semester. I'll be adding in a new one for today. In fact, it's about time for me to shut down this recording.